So here's some remarks about parallel computing, and I just want to introduce MapReduce. The next speaker, who has pioneered the use of MapReduce in biology, will tell you a very exciting and interesting example. And here we have, so that we will discuss this, as I say, in more detail tomorrow. And MapReduce, if you like, is the cloud version of MPI. MPI is famous in high-performance computing for supporting parallel computing. And MapReduce, I have a slide a little later on explaining the exact difference between MapReduce and MPI, but it does the same type of thing. It coordinates the different components of a parallel job. So here we have a picture from Judy Chu's and her students about explaining MapReduce. So Sam wanted to make some fruit juice, and so he used a blender to chop up his apple, and then he expanded it, and he had a map. The map is the mapping of the apple and the orange and the pineapple into slices. That's the map operation for this application. And the reduce operation is forming the juice. That's combining the things together. And then he commercialized this idea, but in order to be successful, you have to run it in parallel. So we had a lot of fruit and a lot of juice. And so this shows basically MapReduce for this problem. You have a bunch of data consisting of different fruits. You run the map job to chop up those fruits. Then you run the reduce job to design the fruits into their different types. And then you store the answer on disk, or in the case here, in bottles of juice. So that's MapReduce. There's a map, which is a processing, and a reduce, which is some sort of concentration. In the case of information retrieval, the map is taking a bunch of websites, finding out, applying the query to each website, and then the reduce operation is taking all the results of those queries and joining them together and sorting them by page rank and things like that. So that's the basic MapReduce paradigm, and that's given in detail. And so that's sort of captured here. MapReduce, we have a map, which is a processing, and a reduce, which is a shuffling and general combining of the results. And we will cover two implementations of MapReduce, Hadoop and Twister, in this summer school. And here's what I promised: here's MapReduce for MPI users. In MPI, we have a communication call, followed by a bunch of computing, followed by another communication call. That bunch of computing is a map operation. It does takes data in memory and processes it in some fashion. That's map. And actually, MPI reduce, which is there's a whole set of MPI reduction operations, they are equivalent to the reduce in MapReduce. Although MapReduce doesn't necessarily have all the reductions MPI does. There are various subtle differences. When people discuss MPI, the data is usually assumed to be in memory. In the case of MapReduce, the data is usually assumed to be on disk. And also, MapReduce has simple automatic parallelization, and also it tends to write all the information to disk. It does not send it to other nodes automatically. Because of writing to disk, it's extremely fault tolerant and also very dynamic. It's very easy to restart MapReduce. If a node goes down, because the results were written to disk, it's trivial to restart. So MapReduce scales tremendously well, scales to much larger systems than MPI does. And there are some slight difference in the reduce operation. For MPI, that reduce operation is either built in, that's how it's normally used, and there's the ability to define a function. But in general, in the say of MapReduce, that's a real program. The reduce operation is a real piece of software similar to the map software. So there are two actual user programs written. Right, so that's that. Let me just skip over. So this slide here makes this critical point that Clouds are particularly interesting for data-intensive applications, but for the reason I mentioned, that data-intensive applications have things like reduce operations done on them. And reduce operations will run well on clouds because they're big operations, and this intrinsic synchronization overhead is not nearly as important as it is for MPI. And so this is one reason you see data intensive running on clouds. Another reason is simple history. Data intensive applications are relatively new, clouds are relatively new, therefore it's natural to put your data intensive application on the cloud. And that's one reason why clouds are particularly useful, particularly seen in the life sciences. The life sciences is an area which is 20 years ago did not have so much software written for it, and so as it's a newer field, it is more natural to bring up new applications on new technologies like clouds. But there is also a technical reason. Data analysis is well suited to clouds. So that's where we are. That's the end of this presentation, and I will stop there. And I guess I can ask if there's any questions.
I have a question. So we did I'm from School of Library and Information Science, Tsinghua Kong. I'm a system architect for the school, and we're dealing with a lot of data, big data transfer. We always having problem like transfer data through World Wide Web, because like a lot of things is like long distance. So we are thinking to use cloud computing to process all our data. But,
yes, so data, so I think library science, library type work is likely to be incredibly successful on clouds, only because Google, Bing, and people, they are doing effectively large-scale information retrieval on clouds. But you emphasize that one important difficulty at the moment is it's not quite clear we have good performance from transferring data from outside the cloud to inside the cloud, and people sometimes complain about that. The only comment I will make is I think once people agree that clouds are a great idea, or we can persuade the IU administration they need to support it, you will find good performance. I believe, in fact, several of the clouds now have Internet 2 connection, but I'm not certain of that. Martin Swaney, who's talking on Wednesday, will tell us about that in much greater detail. But that's certainly an area. But I don't think there's any reason why clouds won't have the world's best communication, because I point out the applications like smartphone applications. What are those? Those are devices on the edge talking to the cloud, and so they certainly have reasonable communication.